Welcome to Quantum Leap. Today we are going to talk about degrees of freedom and configuration space. The minimum number of independent variables or coordinates required to specify the position of a dynamical system consists of one or more particles is called the number of degree of freedom of the system. For example, the motion of particle moving freely in space can be described by a set of three coordinates, example xyz, and hence the number of degree of freedoms possessed by the particle is 3, which means the number of degree of freedoms required to describe the position of particle is 3. Three coordinates require x, y, z. The motion of system of two particles moving freely in space. Uh, it can be described by the position to require two set of coordinates, three coordinates, okay, two sets and three coordinates x1 y1 z1 x2 y2 z2. Hence the number of degree of freedom is 6. Here I mentioned the motion of the system of two particles. Between these two particles there is no constraints. I didn't say anything about constraints till now. So two particles are moving in space. So we need to describe these two particles. We required a set of three coordinates. Okay, to describe such system. If a system consists of n particles moving freely in space, we need three n independent coordinates to describe its position. Hence, the number of degree of freedom of the system is 3n. The configuration of the system of n particles moving freely in space may be represented by the position of the single point in 3n dimension space, which is called configuration space of the system. The configuration space for a system of one freely moving particle is three-dimensional, and for a system two freely moving particle it is six-dimensional space. So the number of coordinates needed to specify dynamical system become smaller when the constraints are present in system. Hence, the minimum number of independent coordinates or variables required to specify the system compatible with the constraints.